Good afternoon, everyone. My name is Lauren, and on behalf of Carasoft Technology Corporation, I would like to welcome you to our Infoblox webinar, DNS Under Siege, Unmasking the Infrastructure Behind Modern Cyber Threats. With that, I'd like to turn it over to our presenters of the day. The floor is yours.
Thank you, Lauren. As Lauren said, my name is Tom Grimes. I run basically our security team over here at Infoblox, and with me I have Ryan Ettle, who's a member of our team. Ryan specifically works with our SLED customers around DNS security. So thanks again for taking the time today. I always like to throw up my obligatory I'm from Buffalo, New York. Most people say, when I say that, do you guys get a lot of snow? And yes, the rumors are true. Even as early as October, we've had big snowstorms. But we're here to talk about DNS and DNS security, not the snow in Buffalo. So why DNS? A lot of times when we start thinking about DNS, and can you use this in your security kind of posture as a company? Can DNS help organizations become safer? Well, one of the things that you look at is a DNS, as I always said, it's kind of like a flight data recorder for all of your network connections in your organization. So I know SANS as an organization talks about, from a forensics point of view, two of the most important logs when they think about it after the fact of a breach is the DNS query and response logs and also your Windows event logs, right? So why is that? The Every single connection typically starts with a DNS query. So before there's a connection, it actually starts with a DNS query, and that for organizations can be logged. We as an organization at Infoblox actually have taken it a next step and said, hey, from these logs, can we threat hunt inside of this DNS query logs? And we've been doing this on and off for over 14 years. Um, and let me share my screen. Thank you, Ryan, for that. I thought I was sharing my screen. And can you see it now, Ryan? Okay. Cannot. Um, hey, Lauren, let me just make sure. Can you see the screen?
In now.
Okay. So, um, thank you, Ryan, for that. So again, when you look at DNS, it is everywhere. So this DNS query and response can support your work at home users, your on-prem users, your cloud infrastructure. A lot of organizations are talking to Infoblox and, hey, can I create a enterprise-wide DNS service for security teams if they want to go ahead and block something? So instead of saying, hey, I want to have to block this in my Zscaler or my Palo Alto or in CrowdStrike, those kind of services don't typically span the entire organization. DNS does span the entire organization. The good and bad of DNS is it is also a query and a response. So threat actors like that because it's a two-way communication. So we have definitely seen threat actors taking advantage of DNS query and response. Actually, it's not only threat actors, it's also enterprise software vendors. Admittedly, companies like Spotify and Canary are actually using the fact that typically DNS is unfiltered, unsecured in organizations, and it's basically treated like a utility, and you can go in and out of organizations. They're using that. I know even back in the day, some AV vendors were actually using their virus DAT file updates over DNS. Now we have seen in the past couple of years penetration toolkits like Cobalt Strike being able to deploy their beacons over DNS. And if you think about it, if we're able to block at the DNS layer, this is before any connection actually happened in your environment. So this is before the three-way handshake and before that connection is set up. So if you can block it in DNS, we actually have seen downstream benefits for your security devices. So if you know it's a bad site or you have some threat intelligence from a particular organization, you want to block it in DNS level, this actually protects it before any connection goes whatsoever. We've actually had one customer, they deployed blocking at the DNS layer, and then their SASE preventer actually called them and said, "Hey, did you change your network? We're seeing less traffic." And again, it's because we're blocking it at the DNS. But it's not just Infoblox that's saying that. Other organizations understand now the benefits of this because you can start to now see all of this telemetry data built into there. So, for example, say we have convicted this one domain as a phishing domain, and it's hosted on a name server controlled by a notorious threat actor. What are the odds that the next domain that gets created to that name server is also phishing? We've actually seen somewhere in the neighborhood of 20 to 50,000 domains can get registered at any one time, and they're all phishing, right? And the concept is we've seen a lot of domains at Infoblox with a lifespan of about less than 1 hour. So again, they want to go use this, and then security tools, security industry puts them on a blacklist, and then they just move on. It's so easy to register and get domains. Um, and then when you think about it, all of this data that we have around this, so that name server that I was talking about, we can reputation rank different name servers. So the name server hosting Infoblox is not going to be the same reputation as the name server that's hosting badsite.com. So everything that we see, whether it's the certificates that are associated with that name server, the ASN, the infrastructure that it's hosted on, we'll start to be able to apply a threat intelligence model to that, and now we can reputation rank all of these infrastructure pieces, and then we can tell organizations which ones should be blocked. Um, and it's not just Infoblox that's saying this. Also, organizations like NIST. NIST is actually updating their DNS deployment guide. They've always kind of talked about protecting the DNS protocol from DDoS attacks or availability type issues. So, protecting the infrastructure and protecting the protocol. Now they're adding a third pillar talking about deploying protective DNS. And exactly what I'm talking about, protective DNS, is taking threat intelligence and incorporating that into your DNS query and response. So if it's a badsite.com DNS query, if you can just take that threat intelligence and tell your DNS server to block that, that is a good best practice as discussed in the NIST Secure Deployment Guide. And what does this provide you? So you as the customer, what does this ability to block in DNS provide you? So I always tell people this is similar to, say you wanted to open your own restaurant. You would have to, and you wanted to have, say, an application and have online ordering. Well, you're going to have to do what everyone has to do, like an enterprise service. You have to create infrastructure, build a website, register a domain, basically enable that domain and operationalize it. Well, this typically starts before the service is created. So this is kind of this head start that if you can start hunting in DNS, we can give you that head start to, hey, there was a new domain that was created or a new domain that we see queried for the first time in our customer data. What are some of those things that we can start to look at ahead of time, these DNS fingerprints? What we have found is on average, we're over a couple of months before the threat actor starts to launch their attack. So if you can convict something based on DNS data, historically you can get a roughly around what we've seen with our customer base is around 68 days earlier than this patient zero. So if you look past the weaponization of these domains, typically what will happen is there'll be a patient zero. And this patient zero mentality of finding something and then telling all of the other security devices in your ecosystem has been this reactive kind of approach. And even companies like Gartner are actually telling their customers they need to be more proactive and preemptive. And that's exactly the fundamental thing that we're talking about with using DNS as a security control. You can now start to do things like, hey, there's this domain that my organization is trying to go to. Let me risk rate that and say, should I be going to it is another discussion. I always ask people, do you know how many top level domains there are in the internet? And most people, the .coms, the .orgs, the .nets, they don't understand how many there are. There's new ones being added almost every year. Google just sponsored .zip and .mov. So now we have domains that look like file extensions, which is kind of an interesting security dilemma that you as a defender are faced with. But there's actually domains that were top level domains that were created as a joke or novelty, like .pizza. And I asked customers, can your mission critical servers go to these domains? There was actually one created .wtf. It means exactly what you were thinking about. And there's about 2 million hosts that are associated with that. It was created as a joke. And I go back to, can your devices basically go to one of those DNS domains? So, just as an example, I wanted to show you a little bit around what does hunting in DNS provide you. So this was something, Infoblox, we do a lot of security workshops and education with customers around the value of DNS in a security kind of ecosystem. And one of the things that we did is we found this lookalike domain. So for those of you that are in the US, Verizon's very popular domain to be spoofed. And here's one where their logos and pages were screen scraped. And if you clicked anywhere, this was a Verizon Enterprise, but instead of an E, it was an I. So it was a common lookalike. They're trying to basically spoof you as a Verizon customer. And if you clicked anywhere, you got one of these fake CAPTCHA sites. And these are all, there's a whole article that was just written around this particular threat actor called ClicksFix. And if you basically clicked anywhere, it started to give you this fake CAPTCHA, which is a new domain, Privacy Shield Online. And it wanted you to paste this script onto your device. And if you did that, you got a information stealer. The whole goal was to try to steal your credentials, known good credentials, and then any of your security devices in line in this kind of reactive or patient zero mentality would have visibility into these domains. So Verizon Enterprise with an I and Privacy Shield Online. So they would do what all good security tools do. They would put those into their indicators of compromise and they would be blocking on those two domains. But if we now pivot over to that DNS metadata that I was talking about, with this particular domain, there were two others that were created that we found by looking at the DNS fingerprints of this particular Verizon Enterprise with an I. So we found two more. One was the Hartford.com with an extra F. And another one was a combo squat of Tesco, online Tesco.com. So these were also domains that we are telling customers they should block. So DNS provided two more domains that you as an organization should be blocking because they haven't been weaponized yet, but they're just as bad as that Verizon one. And then if we look at the actual payload and where that payload was delivered, we found an additional 24 domains. So again, these were domains that were created that haven't been weaponized yet, but they're just as equally as bad. So by looking at the DNS metadata and being able to pivot across this, you as an organization, instead of blocking, say, two domains, now you have the ability to block 27 domains. And again, this is why we at Infoblox feel very confident that using DNS in a security control does provide customers that defense in depth, right? So you're not only protecting the weaponized ones, you're also protecting the ones that the threat actor will pivot to as well. So when we think about this, this particular campaign was actually attributed to a threat actor. And so what we do is we take a look at all of the different DNS metadata, and then we'll put this data into a cluster. And then if we have a cluster and it's doing a lot of things, we'll actually publish on it. And what we're doing is our taxonomy are all based on animals and the DNS technique that we are viewing this particular threat actor in the wild. So, for example, if it's a traffic distribution system, there'll be a viper. If they're trying to abuse, say, kind of the DNS name, it will be a seahorse. In this particular one, if it's trying to do, say, DNS exfiltration or infiltration over DNS, it'll actually be a dog. So we'll talk a little bit about some of these threat actors that we see out here. But when you think about it, this is one example that we saw of the power of using DNS. So there was a domain that was registered, rasapool.net, and it was actually registered on May 4th. And this domain was actually used in the Black Basta ransomware campaign, and you are able to do this kind of forensics after the fact. But with this domain, it was registered on May 4th. It was in our info block. So again, our threat analysis team will see these new domains, will classify them. This was roughly around 26 hours that were clock hours different. That's why it looks like it's 2 physical days, but it was roughly around 26 hours. It was in a block list from Infoblox. So there is that gap of protection if this domain is actually weaponized right away. And we created some algorithms to actually help you as an organization to shrink that gap to around 5 minutes. But with this particular one, we keep track of when do our customers go to it as well. So this was in our block list on May 6th. The first time any one of our customers in our global footprint went to that was on May 9th. So this was roughly around 3 days worth of protection before the actual threat actor weaponized this particular domain. On May 10th is when it was publicly announced, based on all the different security vendors, whether it was Palo Alto or Cisco or Zscaler. So they basically had that in their threat feeds of their product. So you can see, based on the attack being launched on the 9th and the security products having it basically on the 10th, it depends on when your security device got that update. You may or may not been impacted by this ransomware. And that's why you'll see threat actors will try to create a new domain and use that for their C2 or for their payload, because what they're trying to do is they're trying to maximize their opportunity for infection between, when the security tools have it and when they can launch their attacks. So this is just one threat actor that we talk about. I always tell people, if you have ever been around a threat intelligence vendor, if you find something, you say something. So you'll notice our intelligence team, we are definitely a content creator for threat intelligence. So we don't just take other people's threat intelligence and repurpose it and put that into our product. We are basically looking at all of our DNS query data and domain data that our customers are going to and trying to uncover bad actors. I always said threat intelligence is a lot like if I say, hey, these are the known bad actors, it's a lot like going into a post office and seeing your 10 most wanted list. Right? I've been in my post office several hundred times. I've never seen one of those 10 people in there. But those are very bad people. Our law enforcement organizations, very trusted threat intelligence providers have said, hey, these are the bad people, and they are bad. Right? But we took a fundamental approach in saying, hey, there are bad people that are coming into your local office. So if we could do a thing like, hey, we want to do background checks of everyone coming into here, well, the pivot to that from a DNS point of view is that's where we're doing it across our DNS query data. We know exactly domains that are being queried and visited by our customer base and new domains that are created by the internet. And we basically take our threat analysis team, our threat intel team, and we have a follow the sun mentality and a global footprint of trying to find these. We're going to publish all of this. And you can see this is just from the last 12 months of different threat actors that we talked about. We've had some really interesting publications where we're actually able to attribute these threat actors to human threat actors, and you'll start to see some of that in our publications as well. So with our threat analysis team, our threat intel team, we're able to take a look at things. And I thought this was kind of interesting to share with the team on how threat actors are really kind of going after and abusing DNS. One of the things we saw in just the last 12 months is over 100 newly observed domains, 100 million newly observed domains. So I always go back to you as an organization. Do you know how many domains that your organization talks to on a daily basis or a monthly basis? You would be surprised. 85% of all of your DNS traffic typically comes from less than 100 domains. It's the other 15% of your DNS traffic that typically comes from anywhere between 10,000 and 50,000 domains. So again, I talked about a little bit about that in the past. Security teams said, "Hey, Mr. Customer, you know what you need to do is just block all new domains because all new domains are bad." Well, this will tell you we had in that 12-month period, we saw 100 million new domains, but only 25% of them, which is a very large percent if you think about it. 25% of all the new domains that we saw in our customer base were malicious. Uh, but you can see if you just blocked all new domains, you would have a very high false positive rate of around 75% of 75 million domains you would have blocked ahead of time that are non-malicious. The other interesting stat that we saw out there is 95% of all of our blocks. So if we say badsite.com, we put that into our threat intelligence list, and now it's in a blockable state. We're only seeing that in one customer. And I think this speaks to how easy it is for threat actors to basically spin up and weaponize new domains. To me, they're like throwaway, whether they hijack domains or whether they register new ones. There's automation and capability, so they can use a specific domain or C2 by customer. And we're seeing that in real life. 95% of all of our blocks we only see in one customer. Now, those 5% we see in multiple customers, but I thought that was very interesting. We also have been publishing a lot on traffic distribution systems. I said this is almost like a three-card Monty, if you or know that game on the street corner where it's find the queen and you're trying to find it. But threat actors are using traffic distribution networks and ad tech, and we see 82% of all of our customer base have queried some of these malicious ad tech vendors. And I'll get into what is this malicious ad tech. But it's over 500,000 domains that we see in our daily blocks that we can attribute to malicious ad tech. So um, we've seen several different techniques being used by threat actors for these traffic distribution or malicious ad techs, whether it's lookalikes, like in the example that I was showing you, trying to get users into other kind of avenues. We see around 28,000, 20 to 25,000 domains, lookalike domains created on every single month. We see a lot with DNS tunneling. We talked about that and how different security tools are using DNS as a tunneling tool. The other interesting thing is we see a lot of domain hijacking. We published a lot around this. There was some very public domain hijackings, whether it was the CDC or some universities. We actually had one Christian university that their site was taken over by a porn threat actor. So again, it's if you have something from a DNS hygiene point of view pointing to a record that you no longer maintain, me as a threat actor, I can go take that over. We've also seen the other aspect of it. If you have domains that are registered and you've never configured the DNS profile, we see, and you're in a vulnerable DNS provider, you can actually take over those domains. We've saw some very public state and local education, public safety type of domains that you would assume are owned by government entities or state entities be taken over by threat actors. And we've published a lot around that. So let me do a little deep dive on this concept of malicious ad tech and why this is so hard for the security industry to solve. Well, not only to solve, but just to have visibility into this. Because what happens is devices and websites will get compromised. And then what will those compromised websites will do is they'll send you into a traffic distribution network. And the traffic distribution network, its whole goal is not to send everyone to malicious sites, but based on things that I can see about your device. Maybe it's where you're coming from, the browser that you're on, the operating system. Are you on a PC or an Android device? And then I'll steer you based on that criteria that I looked at. I'm going to steer you towards different things. So if I send you like 99% of the time to an ad, you might classify this as a security tool. This is an ad network and it's fine. But if 1% of the time I send you to a malware download site, or it's maybe a script that I want you to run, now this is just harder for security tools to classify this and block this because they'll think you're actually illegitimate. And again, this is one aspect of it. And we've seen different threat actors will use multiple TDS networks. So you have to go through this huge game of what we would call like Plinko, and you can come out and you might go to a legitimate site or a redirected site or a malicious site. And it really depends on when does the threat actor want to turn on the Plinko machine and when do they want to turn it off in some cases. And we've seen that as well. Um, and when you start to look at the data behind it, we see these particular threat actors in a majority of our customers, somewhere 50 to 70% of the time when we start to classify these new traffic distribution networks. And some of them have millions and millions and millions of domains that they'll use and have access to. And they run the gamut to scams, to dating site malicious intent. We've also seen malware, credential harvesting, and just plain old gambling and porn as well. But it's interesting when you think about it. It's so easy now because of how large and scalable these sites are to be able to become very, very popular. I know, and I used to work at another DNS security company, and they used to bank on if the site is popular, chances are it's not malicious. We're going to let it go through. And this is basically our new research has actually shown that popularity can be very easily obtained by these threat actors. We saw one threat actor, it took them 19 days to be as popular as PaneraBread.com. And that's 2.5 times faster than it was just last year, and 40 times faster than it was just 5 years ago. So it's very, very easy for these threat actors to be in these top ranking sites. So when you think about is it just Infoblox that's talking about it? No, Palo Alto and Zscaler and CrowdStrike and all these trusted threat intel teams are also talking about how these traffic distribution centers. But again, because they're not a DNS company, they're not typically looking at DNS queries and responses. Sometimes they have to wait for that patient zero. So that example that I showed you, that would give their threat intel team to kind of pull the threads back and find it. The interesting thing is I did this for a customer that said, well, hey, I've got a next gen firewall. I'm going to be fine. They're going to find this stuff. So that Palo Alto, their Unit 42, we collaborate with them on a company level, but they were basically talking about this one particular threat distribution network, and they published this on May 20th. So they do these things called timely updates, and they'll tell you, hey, you should be blocking these domains. So just as a curiosity, we looked at it, these domains, and turns out we were blocking them. They were already in our block list back in April. So this is that window of extra availability of that time being early or preemptive on your security posture. In this case, it was 30 days. Like I said, on average, we find about 68 days before. So in this case, we were 30 days. Honestly, all you need is 1 day. 1 day before the attack comes, you'll be in good shape. In this case, we were 30 days earlier. But then this one particular reseller asked us, well, hey, are you just cherry picking these Palo Alto timely updates? And I said, okay, well, that's fine. Palo Alto, they publish all their timely updates to GitHub repository. So let me take a look for the last 2 years. Let's take a look at all of this. And does DNS provide an extra level of protection? And in this case, from Palo Alto's threat intelligence updates, there were 3,715 indicators that you would block as a customer. So domain names that you would block. 1,900 of them were already in our block list because DNS provided that intelligence. So in this case, 52% of the time, you would have been already protected from a basically a threat that Palo Alto was telling you about. This also shows how DNS and threat intel vendors like a Palo Alto create a defense in depth because 48% of the time they found something based on their threat intelligence. So this is definitely where a better together message from a firewall or a CrowdStrike EDR and also DNS security. So next, I wanted to go into one of these threat actors, and this is one that we call Detour Dog. We just published about this on September 30th, and I thought this one was very, very interesting and how stealthy it was. And this is a new technique we've actually seen from the threat actor. So there was a compromised website, and hackers are always out there. This was a WordPress site, and so the particular domain that they took over. Then, when they took over that website, they were able to use server-side DNS queries to trigger to a traffic distribution network. In this case, we're calling that threat actor Decoy Dog. The interesting thing about this threat actor is that the payload, the malicious payload, was actually stored in a DNS text response. So the script that they wanted this compromised website to run was actually in the DNS text record. So if you went to the site itself, the site was fine. The actual malicious payload was actually housed in the DNS text record. Again, they're trying to hide and evade security blocks and detection tools out there. So then they deployed their basically their first downloader called Starfish, right? And then when the victim machine had this Starfish downloader, it talked to an additional compromised site that used the same kind of command and control over DNS to Detour Dog, and it provided the secondary payload, which was the Strela information stealer. So again, these are server-side DNS queries. So the only way you would see this is a global DNS provider. So this was something that well, we got alerted to because we had Detour Dog as an infrastructure actor, and we were monitoring those domains, and we had them in a block list. And a threat researcher at IBM said, "Hey, this domain that you guys are publishing around, I'm finding them deploying this information stealer." But so then what we did, we worked in collaboration with with IBM on this, and they actually took down one of the domains and they took it over for around 48 hours. And what we found is then we basically saw millions and millions of DNS text records that we could then pivot over to what exactly is this threat actor doing? And this is why it's so hard to find these threat actors in the after the fact or the patient zero, because 90% of the time they did nothing. And then 9% of the time, of all of the DNS text records we looked at, 9% of the time, they sent them to a legitimate ad network. And our hypothesis is they have to keep the lights on. They're trying to generate ad revenue and money. So they took 9% of the traffic and sent it to there. And then 1% of the time, it actually used the DNS text record to fetch and execute a file from a remote location. And then that was those server-side responses that I was talking about. So it's very, very stealthy in the sense that if you were looking at this, if your security tools, and a lot of times we'll see threat vendors, if you're not looking at the DNS, you may just say, oh, this is ad networks, or oh, this is a benign network. It's a parking page. They're not doing anything. And again, this is where you really have to see the full scope of this. And the only way to get that full scope is to look at these DNS queries and responses. So in this particular case, we found over 30,000 infected websites. And we've been working with law enforcement and threat providers to kind of reach out and have conversations with these customers because they're unwitted participants in this threat actors network. And they're using this kind of double way of bringing down the downloader, the Starfish downloader, and then also trying to bring this information or credential harvester, Strela information stealer. And we've classified this actor as decoy dog, but it was also kind of overlapping with some other threat actors that we've seen. So we definitely think there is this kind of threat actor collaboration around some of these infrastructures like these traffic distribution systems. It's almost they're setting up to be specialization ransomware or malware as a service kind of thing. So you, as a threat actor, can sign up for a network cloaking capability with some of these traffic distribution networks. So this is very stealthy, very, very harmful if you're one of the individuals that gets your particular sites compromised or participates from that victim to these downloaders or credential information stealers. And we've seen this across North America and Europe. We've also seen them from an affiliate point of view, like I said, working with other threat actors. One of the ones that we've been profiling a lot around is Vextrio. And when you start to look at some of these infrastructure actors and how they manipulate, we've also seen things like Scattered Spider and different threat actors will use some of these cloaking capabilities by these threat actors, and they're very common in deployment of DNS-based malware. So again, we just published this, so you can go to our Infoblox blogs and you'll read all about the technical details if you want to see exactly. I think it's kind of a creative new way that threat actors are using DNS text records to try to evade detection. You can read all about those technical details and how our team actually pulled at the thread and uncovered this threat actor. So, what we talked about today is all around how you as an organization can get better control from a security point of view directly by using DNS as part of your security control devices. So, a lot of times when we start thinking about all of the threat intel, and I just showed you that example of, hey, Palo Alto was telling their customers to block a whole bunch of these domains. Well, 52% of the time it was already in there. We as Infoblox, we created a tool so that you can see how your security stack stacks up to these DNS-based domains that we're telling our customers that they should be blocking. So we'll run them based on these different categories, known malicious, C2, phishing domains, these traffic distribution domains. So you can run this test. We call it Infoblox Inspect in your existing security environment to see exactly where your particular gaps are around, whether it's using DNS for exfiltration or infiltration, or actually some of the threat intel characteristics. So we do have this capability, and you can schedule a time to have this run in your organization, and then an expert to run through the Infoblox inspect results and let you know exactly where your security stack stands up. So with that, Ryan, any questions come in so far?
I don't have any questions. Does anybody want to ask some questions inside the Q&A chat?
I think we have, I could start us off with one, kind of get the conversation going here. How does DNS telemetry help uncover threats that bypass traditional endpoint and firewall defenses?
Yep, Lauren, thank you very much for that one. So, as we kind of talked about in the presentation, DNS gives you kind of those fingerprints that you can look. So, that example that I showed you, where it was that Verizon Enterprise website and the additional domains that were both used as kind of lures, right? So, Verizon Enterprise and Hartford, the Hartford with one extra F. So DNS is going to give you the telemetry of these pre-weaponized domains. So if you're going to block, I always said if there was a domain on a phishing infrastructure and there were 69,000 other ones, wouldn't you want to block those two as well? But a lot of times security devices, whether they're your EDRs or your firewalls, will wait until it's confirmed malicious, not necessarily blocking these pre-weaponized domains. So DNS can definitely give you this kind of ability to be preemptive and block those domains ahead of time. Gartner is actually coining this preemptive security, and Infoblox is getting put on those vendors, their little, I forget what they call it, their magic quadrant around that. But it's again preemptive security, and using DNS will give you a lot more domains that you should be blocking as an organization ahead of time.
Perfect. Moving on. What are some early indicators in DNS traffic that suggest adversarial AI is being used in an attack?
Yeah, so when we look at DNS query data, and this is that whole concept of can you use behavioral analytics? So we see this a lot where we'll call this in our behavioral analytics product, it's called zero-day DNS. So what does that mean? We're seeing, because again, DNS query data should be very predictable, meaning if it's an enterprise application like, Salesforce or Clary or, you name the application, we're going to see it in multiple enterprise customers. So we've actually created an algorithm that we can say, hey, Mr. Customer, this is a domain we have not seen in your environment. So this is new to you, but it's also new to Infoblox. And those two things taken together are a red flag for you as an organization. So you should be able to block or quarantine or just log, right? We have some customers that want to take a very conservative approach and they'll actually log it. I can say with this product, we haven't had any false positives, right? Because again, if it's new to us and new to you, chances are it's not business impacting. And what we have seen, we've been running this for roughly about a year, this new technology, and we haven't had any reported false positives on that.
Perfect. Okay. Our next one is how often do you see threat actors utilizing their own infrastructure that can be fingerprinted, versus commercial services that serve legitimate DNS traffic?
Yeah, so once, and it's very interesting when you start to look at our threat posts, right? So we're doing a lot of publications from people in our threat intel team. So Dr. Renee Burton, Dave Mitchell, Cricket Lou, they're always posting around this technology and these threat actors. And what we've actually seen is that they'll create fake profiles and follow these threat intel teams. So we did see them, but because we're monitoring not only just one aspect, which is the IP infrastructure, but we can monitor where these domains are flowing from and to. So a lot of times we'll actually see it with that one threat actor that I was showing you. There was around 70,000 domains that we saw go from their infrastructure over to Cloudflare. So again, we're maintaining it. We're cloud agnostic, so we don't care if it's on-prem or in a cloud or wherever. We're going to do our DNS-based analytics, and then we'll be very precise. So we wouldn't block things like, Amazon AWS or I know Amazon's probably a bad example with their outage this week. But again, we'll be able to monitor both on-prem and cloud because we're looking at the DNS metadata.
Okay, thank you so much. Our next question is, can you walk us through how a threat actor like Vextrio Viper uses DNS infrastructure to scale attacks?
Yeah, so this is one of the things that we see them a lot is creating new infrastructure. So it is so easy to register and take over domains. We've seen this a lot when you look at it. There's 1,589 domains, and what we see is these infrastructure actors will go after different TLDs, and then once those TLDs get kind of put on security lists, then they'll pivot over. A famous one is .xyz. We actually had one customer that said all of their phishing attacks were coming from .xyz. They had no business reason to talk to that domain. There's no allowed domains that are in there. So they just blocked that and they saw what 48% of their phishing just go down just from that one thing. So their security tools like their proof points didn't have to kind of block those domains. It was already blocked in the DNS infrastructure.
Okay, next one. What are the most effective ways to use DNS intelligence for brand protection and fraud prevention?
Yeah, so within our tool, you can monitor your own domain. So, say for example, we talked about me creating a restaurant. I would say Tom Grimes, and I would have my domain watched. And then our algorithms are watching different domains as they get created, new domains that we see pop up. We can trigger those based on lookalikes. So, for example, one of our customers, Disney, right? But I can create a lookalike, Disney Marketplace, Florida.com. That's not necessarily a malicious site. So we'll take our threat analysis team and have them look at it. And then we can see, okay, is this enough to be blocked? And we'll actually start putting that into a block list. So without you having to do anything, other than just tell us to watch this domain, we'll start to find lookalikes, which will give you visibility to. But then the better thing for you and all of your customers is we'll start to put those malicious lookalikes into our automatic blocking feeds.
Okay, thank you. I think we probably have time for about one more. How does DNS tunneling differ from other covert C2 techniques, and what detection strategies are the most effective?
Yeah, so DNS tunneling for me is just the and it goes back to if you guys remember the attack against SolarWinds, the source code that got manipulated there, and it was DNS. They were basically using a domain for their C2, and they wanted to tell the malware what to do and when to do it. And they created this very ingenious kind of way that the IP address, based on the IP address that would be returned for that particular domain, the malware was going to do different things. So if it got a Google address, it did this. If it got an Amazon address, it did this. And if it got a Microsoft address, it did this. So it was a real quick and easy way to get information and be able to share that back and forth with the particular piece of malware. So really, when you think about it from a behavioral detector, you need to see when these queries and responses violate that kind of normal, what we accept, that expected behavior. And that's really the tough part. And that's where companies like Infoblox, we have a lot of patents around this. Because we are a DNS provider, we see global DNS and we can see threat actors and how they're changing it. We've had to create new signatures based on new attacks, but you need both signature-based protection and behavioral-based protection. And I think it's the combination of both that provide customers the best level of protection. What we have found and this is something not to toot our own horn, but in the Infoblox Inspect, we can actually show you this. Most security tools have a tough time finding malicious DNS tunneling in particular DNS requests because you have to be a DNS server to understand what's going on across these DNS requests. So, for example, we have certain next-gen firewalls that say, hey, we block DNS tunneling, but yes, that's only on the A record. If you move over to a text record or an MX record or an SOA record, it goes right through the device. Because again, it doesn't know how many DNS record types there are. And to find DNS tunneling in each of those, you have to look across the whole DNS stream. And that's exactly what Infoblox does.
Wonderful. So thank you again to our speakers, Tom and Ryan, for being with us this afternoon, and to all of our participants who joined us today. We hope that this webinar has been helpful for you and your organization. If you have any further questions, please don't hesitate to call or email us. Thank you so much and have a wonderful rest of your day.